Hi, welcome once again to our YouTube channel. Thanks for subscribing to our channel. We really appreciate it. It's nice coming along with us. Quickly, we want to take a look at a particular section of a topic, and the topic is gas law. So we want to look at a section of it talking about Boyle's law. So that is just what we want to look at today. So I've come across a series of questions on what Boyle's law is and how it is applicable in gas laws. So today I will talk about Boyle's law. I will help us to understand what Boyle's law is, and then we will solve one or two examples on this same topic. So quickly, we said we're talking about gas laws, and the aspect of it we are looking at is the Boyle's law. So what is Boyle's law? What is Boyle's law? Boyle's law, actually, it is a particular topic that was postulated. It was made by a particular scientist called Robert Boyle. Now, in the year 1662, that was when he postulated this, and it came into the study of chemistry, or the study of gas law, so to say. Now, while he was talking about gas laws, he actually made this clear that there is a relationship between volume and pressure. So the relationship between volume and pressure is what Boyle was able to put down for us in this particular topic, and that is what we want to look at right now. So talking about this, we'll be having Boyle's law. Boyle's law states that the volume of a given mass of gas is inversely proportional to its pressure. It's inversely proportional to its pressure, provided that temperature remains constant. Yes, that is what Boyle's law was able to tell us. He said that at every time that we have volume, that the volume of that gas will be inversely proportional to the pressure of that gas. And so that was the relationship that Boyle was able to bring about, talking about gas laws. So how can we get to understand what this is actually talking about? Let me show us mathematically what Boyle was trying to say. Mathematical representation of this. Mathematically, what Boyle was trying to say is that volume is inversely proportional to pressure. That is what Boyle was trying to say. So how do we make sense out of this? Talking about this, let us see what it will look like if we are to bring it into a mathematical equation. So let us bring this out of the equation. Let us change this proportionality sign into introducing a constant to it. So if we're introducing a constant to it, our proportionality sign changes into equal to, and then we'll be having k over p. The k there is the proportionality sign. So if you have b equals k over p, that invariably means that it will be like this. We'll be having vp equal k. So I can also rewrite it to be k equals vp, and that invariably means v1 p1, and then we could be also having equal to v2 p2. So this is just what Boyle was trying to talk about. There is a graphical representation to this, and that is what I want to put out here. Looking at it graphically, what Boyle was trying to tell us is that every time we have, this is origin O, let's assume we have our volume here and we have our pressure here. Every time we have our volume increasing, we have pressure decreasing, and in a vice versa, when volume is decreasing, pressure is increasing. So look at this. Volume at this point here is decreasing, and as the volume is decreasing, the pressure is increasing. We can see what is happening to volume and what is happening to pressure simultaneously. we can see. So here we have our V1, V2, V3 and V4. And here also we have P1, P2, P3 and P4. So this is basically what Boyles was trying to explain to us when he said that the volume of a given mass of gas is inversely proportional to its pressure provided that temperature remains constant. So having understood this, now let us just take one or two examples. One, it says 470 centimeter cube of a gas with pressure of 870 millimeter mercury has its volume increased by a half of its initial. Have its volume increased by half of its initial. Calculate its new pressure. Calculate its new pressure if temperature remains constant. Calculate its new pressure if temperature remains constant. Now, at this junction, there is already a signal that will help us to understand that we are talking about Boyle's law. But perhaps you were not told. We are actually understanding this because we are talking about Boyle's law. That is why the question is straight to us now. But in a scenario where you were not given a clue, you have been given a clue in the question. Now, telling you that temperature remains constant and that there is a relationship between pressure and volume is already signs that we are talking about Boyle's law. It is only in Boyle's law that we have a relationship between pressure and volume where temperature is constant. So having this now, how do we go about it? Remember that we said Boyle's law mathematically is V inversely proportional to P, and after working we have it to be V1 P1 equal V2 P2. That is what we will be using to solve this particular question. But before you be able to do that, you need to be able to identify your parameters. What are the parameters that you are given? What are the values that you were given in the question? If you are not able to identify these values in your question, you may not be able to solve the question. So let us look at it now. The question says 470 centimeter cube of a gas with pressure of this. So we could assume that this is our V1 and this is our P1. So V1 equals 470 cm cube and our P1 equals, because at this volume the pressure is this. So we have it to be what? 870 millimeter mercury. It should be noted that your pressure could come in at least three forms. Your pressure could come in form of millimeter mercury, it could come in form of atm, it could also come in form of Newton per meter square. It could come in any of those three or even more, but at least I'll be making use of this. Now, we have our V1 to be 470 centimeter cube and our P1 is 870 millimeter mercury. And so let us see. The question goes down. He said it has its volume increased by half of its initial. So half of the initial volume, that is half of 470. So that means our V2 is 470 plus 470 divided by 2. So we have here 470 plus 470 divided by 2 is going to give us 235. So V2 is here. We have 470 plus 235. That is going to give us 705. So 705 centimeter cube is our V2. So we're now told to calculate its new pressure. To calculate the pressure at V2, to calculate P2 at V2. So this is what we're actually looking for. So you see how we've been able to actually deduce, because we're not given this directly. We have to calculate it out. So these are the parameters. We have our V1 to be 470 centimeter cube. We have our P1 to be 870. We have our V2 now to be 705 centimeter cube, and then our P2 is what we are looking for. Solution. We are making use of this value here. This value here is what we are going to make use of. That is the formula that we'll be using for this question here. So we have our V1 P1 equals V2 P2. Here now, since we are looking for P2, let us make P2 subject of the formula. Making P2 subject of the formula, we will have what? P2 equal V1 P1 over the coefficient of P2, which is V2. So let us bring all of this into the equation now, what we have here. So our P2 equals, our V1 is 470. We have 470 multiplied by our P1 here is 870. 870 divided by our V2, we have it to be 705. So that is what we have there. So let us do the calculation and see what our value will be like. Calculating this now, we have 470 multiplied by 870. So that is giving us, we have 408,900 divided by 705. Divided by 705 is giving us 580. 580. Since it is our pressure that we are looking for, and our pressure is in, we have it to be in millimeter mercury. So this is what we are having here. So this is the final answer for this particular question. So if you look at it now, at this point here, when volume is 470, or when volume at the V1, when volume was 470, pressure was 870. By the time volume, it's look at it now, V1 was 470, now our V2 is 705. That means our volume has increased from 470 to 705. So reverse is what is going to happen to the pressure. If volume has increased, pressure must decrease. That is what you are saying here, that there is what? In Boyle's law, it is what? An inverse proportionality. So our pressure decreased from 870 to 580 millimeter mercury. So that is about Boyle's law. Let us take one or two more examples. Example 2. A gas has a volume of 600 centimeter cube at pressure of 2 atm. Calculate its new volume. Calculate its new volume when its pressure changes to calculate its volume becomes or changes to twice its initial amount. So this is similar to what we have done before. We have our V1 to be 600 centimeter cube. So the question there says, at this volume of 600 centimeter cube, the pressure was 2 atm. P1 equals 2 atm. And so our V2 now, it says calculate the new volume when the pressure changes to twice initial amount. So here we're looking for V2 because our P2 is twice the initial amount. So that means we have what? We have our ATM to be 2 times 2. 2 times 2 ATM. So that is giving us 4 ATM. So we are looking for our V2. So as usual, we are using this formula V1 P1 equals V2 P2. So here, since we are looking for V2, let's make V2 subject of the formula. So we have it to be V1 P1 over P2. So using that now, we'll be having V2 because our V1 here is 600 multiplied by our P1, which is 2, divided by our P2, which is 4. So here now our V2 equals 600 times 2 will give us 1200 divided by 4. So our V2 invariably becomes, we have it to be 300. 300, so centimeter cube. So if you look at it now, the volume was 600, now it is what, 300, because the pressure has what, multiplied by 2. So basically that is what Boyle's law was trying to talk about when he was explaining gas laws. Thank you for coming along with us. Perhaps you have any other question that is related to this that you want us to help you out with, you can actually put it down in our comment section. For those that are yet to subscribe to our channel, please subscribe to our channel and don't forget to click on the notification button so you get easily notified when next we upload our content. Thank you very much for coming along with us. Please stay tuned to our videos as we'll be bringing more interesting topics to you.